Okay, so we are going to do some rotor example questions. When you get to see these rotor example questions, often we are given a lot of information. We may not always need it, and we may have to use certain information and take a few steps before we get to what we got to find. So here's an example here. Take a minute, read through that, and then I'd like to see you construct a rotor chart. And so this way we can kind of keep it organized, all of our values that we need. So I'm going to do that right now. And so here's a rotor chart, and you should commit these rotor chart to memory. So we got percent slip right here, slip RPM, rotor RPM, E of rotor, R of rotor, XL of rotor, Z of rotor, power factor, I rotor, I active or in phase current in the rotor, and then the rotor frequency. And the way that we do it is we'll put the 100%, or we also call that blocked rotor values at the top. Blocked rotor values. And they're giving us values at 75%. So I'll make another row here. And then they're also asking us to calculate a value at 30%. So based on the information given, at 75% slip, it says we have a slip RPM of 2700. We've got a rotor speed, the actual speed of the rotor is 900. We've got a voltage of 1.25 volts. The resistance is 1.5 ohms. And it's asking us to figure out what is the rotor voltage at 30% slip. So it wants to know this. Okay, oh, did I miss XL? XL is 2.5. So we actually aren't even going to need the resistance or the XL to answer this question. We're going to go ahead and convert the value that we need, so which is the voltage, to figure out what is its voltage at 100% slip or blocked rotor. So to do that, let's just write out the normal formula. We know that the rotor voltage is proportional to the percent slip. So E of the rotor, we would say E breakdown of the rotor times percent slip. So if I wanted to calculate what the breakdown, what the blocked rotor voltage is, blocked rotor, I'm going to take my E of my rotor at 75%, and I'm going to divide it by my 0.75, or 75%. So E of the rotor is 1.25, so I'm just working this backwards, divided by 0.75, and that's going to come out to about 1.667 volts. Okay, so I go ahead and I'll put that value up there. So 1.667 volts. Now I need to bring that down to what is the voltage at 30%? Well, same formula as we have here. So the E of the rotor is going to be equal to my E blocked rotor value times my percent slip. So E blocked rotor is 1.667, or 100% slip, and times it by 30%, or 0.3. So that will come out to about a half of a volt. So 0.5 volts, and that's your answer. Okay, so just using this chart and navigating up and down different columns is a lot of what these questions are about. So let's try another one here. So we got a 6-pole 480 volt, 60 hertz, 3-phase skim. Our E blocked rotor is 6 volts. XL blocked rotor is 3.5. The R of the rotor is 1.5 ohms. And has a full load speed of 1162 RPM. It says determine the percent slip when R of the rotor and XL of the rotor are equal. And we call that breakdown torque. So what percent slip is that? So best place to start is to construct a little rotor chart, and I'm going to go ahead and put my blocked rotor values here. So BR meaning blocked rotor, and that means 100% slip. That means the rotor is not moving at all. So next thing we're going to do is it wants to know our values are percent slip, so our percent slip at breakdown. So breakdown occurs when the R and the XL are the same, or a 45-degree triangle on our impedance triangle. So voltage 6 volts here. If we wanted it, we could put that in. The resistance of the rotor is 1.2 ohms. The XL at blocked rotor is 3.5 ohms. We know that the ohmic value of the rotor on a standard skim stays the same, so no matter which one we're working on. So it's going to be 1.2 ohms at breakdown value. And at breakdown value, we know that XL is going to be the same value as the resistance. So that's going to be 1.2 ohms. All right. So now we're just going to use these values of XL to figure out our percent slip at breakdown. So the original formula, if I want to calculate the XL, all I got to do is take my XL at blocked rotor value and times it by the percent slip. So if I want to know what the percent slip is, I'll just take my XL that I know and I'll divide it by XL blocked rotor and times it by 100. So 1.2 divided by 3.5 times 100. And so that should work out to about 34.29%. So 34.29%. So that would be what we'd fill out here. All right, good. Let's try one more example. A three-phase 60 Hz skim has a blocked rotor reactance of 1.9. The rotor reactance at full load is 0.095. What's the percent slip? So very similar to the one we just did. So 100% slip, and full load is going to be around here somewhere, and it wants to know what is the percent slip at full load. Well, we could just use the values given. So at blocked rotor, we're 1.9. At full load, the reactance is dropped down to 0.095. So same formula, XL is at full load would be equal to XL blocked rotor times my percent slip at full load. Okay, so we're going to determine the percent slip at full load. Full load would be equal to the XL full load divided by the XL at blocked rotor value times 100. So that's 0.095 divided by 1.9. And that will work out times 100, times 100. That should work out to be about 5% slip. So 5%. Okay, that was the first of 2 parts to some example rotor chart calculations. I'll see you on part 2.